Welcome to chemistry class with Anekwe Christopher GK, your chemistry teacher. Of course, we have a video and we have a topic we're going to treat today, which is very, very important in chemistry and in chemical industry. But still remember, before we continue, if you have not subscribed to this particular channel, do well to do so by subscribing to this channel. Just hit the red button. You can see on your screen now, and you are good to go. So that whenever I upload a new video, you have a notification for that. All right, today we will have a topic titled catalysts. Catalyst is the topic we have today, and it's expected by the end of this particular class, you should be able to learn how to define catalysts and give at least one difference between positive catalyst and negative catalyst. You are able to define catalyst by the end, also give difference between positive catalyst and negative catalyst. Now, number two objective we are to achieve by the end of this particular class is you should be able to explain the two types of catalyzed reaction. Able to explain a catalyzed reaction, two types. Then another one is to give at least 4 characteristics of a catalyst or catalysts. Number 4, you should be able to, with the aid of examples, explain enzymes. So you're also going to learn about enzymes in this particular video. Then number 5, you should be able to mention 2 properties of enzymes. Then lastly, you should be able to state 4 uses of enzymes. So these are the things we want to achieve by the end of this particular class. So let's follow them one after the other in this video. All right, let's begin by saying what actually is catalyst. We must have been hearing of that. Of course, catalyst is a language we must have been hearing in chemistry. But what is it? A catalyst is a substance that alters the rate of chemical reactions. A substance that alters the rate of a chemical reaction, but itself remains chemically and quantitatively unchanged at the end of the reaction. Of course, it alters the reaction, but itself remains chemically unchanged by the end of the reaction. It partakes in the reaction, it has effect on the reaction, but itself remains what it is. All right, something like iron in the Haber process, we use it. That is for manufacture of ammonia. Iron is used as a catalyst. So iron is an example of a catalyst used in a Haber process in production of what? Ammonia. We use also vanadium 5-oxide. We use it in manufacturing of tetraoxosulfuric acid. We use vanadium 5-oxide as a catalyst. We use iron as a catalyst, and other catalysts we have. They alter the rate of chemical reaction, but themselves remain chemically unchanged at the end of the reaction. Okay. We have types of catalysts, positive catalysts and negative catalysts. What do we mean when a catalyst is positive? When we say that it's a positive catalyst. A catalyst is positive if it increases the rate of chemical reaction. This is the catalyst that increases the rate of chemical reaction. Some typical examples are biological catalysts like amylase, maltase, and lipase, and all of that. There are popular example we know in biological as a biological catalyst. We still have that of the chemical aspect of it, chemical catalysts. In the chemical aspect of it, we still have manganese 4-oxide, which speeds up the decomposition of potassium triosochlorate 5. What we just mean here is this. If a reaction would have taken something like 5 minutes, by the use of positive catalyst, it reduces something like 3 minutes or 2 minutes or 4 minutes, but the time that would have taken for the reaction to be completed ordinarily will be lessened because catalyst is speeds up the rate of chemical reaction. The reaction occurs faster. So we can see equation on the board on your screen where manganese 4-oxide is being used as a catalyst to fasten the decomposition of potassium triosochlorate 5 to produce potassium chloride, and oxygen gas will also be given off. So that is a reaction of positive catalyst. It increases the rate of chemical reaction. It makes the reaction to occur faster than the way it would have been ordinarily. All right, but what does negative catalyst do? Negative catalyst, what it does is that it decreases the rate of chemical reaction, as you can see. Now, what I want to say about this is the definition of catalyst is a substance that alters the rate of chemical reaction. Don't just say that a catalyst is a substance that speed up the rate of chemical reaction. No, what does that is positive catalyst. Negative catalyst decreases the rate of chemical reaction. That is it. All right. Two types of catalyzed reaction. When a reaction is being catalyzed, we can group them or classify them into two. One is homogeneous catalysis, while another one is heterogeneous. Homogeneous, homo means same, hetero means different. Now, in homogeneous catalysis, what it means is that is a kind of reaction in which the reactant particle, the product form, and even the catalyst are in the same phase. What we mean by that, in the same state. If they are solid, all of them, both the reactants and product and even the enzyme, the catalyst, all are in the same phase, the same state. As you can see now, sulfur oxide and oxygen, or their all gases, nitrogen, the oxide of nitrogen that we use, and the sulfur oxide we will use, that means triazosulfate sulfate 6 oxide that we have here is also gas. All of them, they are all gaseous. They are all in gaseous state. So that's what we mean. When all of them exist in the same state, we call it what? Homogeneous catalysis. It's being catalyzed, a catalyzed reaction that all of the reactions, all the reactant product and the catalyst involved on it are in the same state of matter. All right, while the heterogeneous is when the reaction occur, or the reactant, the product, and the catalyst are on different phases. We can see that nitrogen is gas, oxygen is gas, but iron is solid. Then ammonia is gas. Now, but that of the catalyst now has different phase from the other elements involved in the reaction. So we call it heterogeneous catalysis because they are of different phases. All right. Catalysts have unique properties, characteristics, as the case may be. One of them is that catalyst does not start a reaction. A catalyst cannot start a reaction. Rather, it is effective only in a reaction which is already in progress. Catalyst does not begin a reaction. It happens, its effect is existing reaction. Now, number two is that catalyst alters the rate of chemical reaction. We know that. Either it lowers the rate of chemical reaction, of course, it lowers the activation energy of the reaction, which makes the reaction to occur faster, which is most common. Number three is that the catalyst will affect the rate of chemical reaction, even though it is present in small quantity. No matter how small a catalyst is, it still affects the rate of chemical reaction. Or only that the rate when it's small and when it's large, in large quantity, may not be the same in their reaction, but it still affects, it still shows its effect in that particular reaction. The next thing now is that the physical appearance of a catalyst may change at the end of the reaction physically, but chemical property remains unchanged. I've said it before, the catalyst remains chemically unchanged and the quantitatively unchanged at the end of the reaction, but physically it may alter. Maybe if it is something is maybe something like whitish in color before. At the end, maybe the appearance may look like something like has been tarnished or brownish or any other color, but the truth is that the chemical property of that particular enzyme, catalyst, remains unchanged. All right, the next thing we need to understand about this is this, that catalyst is specific in action. Catalyst is specific in action, meaning that a given catalyst will act on only one particular reaction. However, many inorganic catalysts will catalyze more than one reaction, but they are specific in their actions. All right, the effect of a solid catalyst is improved by increasing its surface area. It could be by grinding it. When you grind the catalyst, the surface area will be increased. It acts faster than when it is solid and then lump. So you can increase the surface area and it affects the rates, the effect it will have in the reaction. All right, so another thing we need to know that impurities can prevent catalysts from working. Impurities affect catalysts and their performance. So the catalyst is said to be poisoned or inactivated by impurities. So that these are the things we need to know about it, and we need to move to another part of catalyst. It's also a catalyst. What we mean by enzyme. Enzyme is also a catalyst, but is a biological catalyst. Enzymes are biological or organic catalysts, typically proteinous. They speed up, of course, reaction by lowering the activation energy. So catalysts speed up the rate of chemical reaction, or rather alter the rate of chemical reaction. Enzyme is catalyst. He does what catalysts do, only that is an organic one. It's biological catalyst. So it's not a chemical catalyst, it's a biological catalyst. That is the only thing. All right, they are vital for life. Enzymes are vital for life, including yourself, and they serve a wide range of important functions in the body, such as aiding in digestion and metabolism. So enzymes in our body help in digestion of our food and the metabolism in our body. So enzymes are organic catalysts that alter the rate of chemical reaction in our body. So we have different examples: the protease, the amylase, the lipase, the lactose, the cellulose, the maltase, and all of that, sucrase. So, and their function, what they do in our body, they break down of protein into peptides and amino acids. Amylase does its own breaking down of carbohydrates. Lipase break down fat and oil, and lactose does its own till down to sucrase, which break down glucose, sucrose to fructose and glucose. We know that sucrase is an enzyme that acts on sucrose. Enzymes on sucrose. Sucrose is a disaccharide, which when break down, it will produce fructose and glucose for energy. So these are the examples of enzymes and their function. These are the examples of enzymes and their function. Still remember, they are organic or biological and catalysts. All right, now, what are the properties of enzymes? What are the properties of enzymes? Enzymes are typically protein, or you can say they are proteinous. Enzymes are sensitive to pH changes. Most enzymes have a certain range of pH at which they work best. So they are sensitive to change in pH or changes in pH. Now they can be made inactive by heating. Too low a temperature will cause enzymes to become denatured, meaning destroyed. Enzymes can be made inactive by heating. It's one of the properties of that. We call it denaturation. All right. The next thing is that enzymes are highly specific for a particular substrate, and enzymes remain unchanged during the reaction or at the end of the reaction itself. Hope you are following what we are saying. And so far, we have talked about catalyst and enzyme and what they do, what their unique properties. But now we are going to look at this particular question. How do enzymes act as catalysts in a chemical reaction? What does it do? What does catalyst actually do? Or what does enzyme do? Still know that enzyme is catalyst. Catalyst is catalyst, and enzyme is also catalyst, only that is the biological one, organic one. All right. Enzyme, what do they do? Of course, they are biological catalysts, and how do they work? And what they do and how they work is they lower the activation energy. Lowering of the activation energy is how catalysts or enzyme do their work. They lower the activation energy, and that lowering of activation energy makes the reaction to be faster. It makes the reaction rate faster. Thus, enzymes speed up reactions by lowering activation energy. Once the energy, maximum energy needs to be surmounted, is being lowered, it makes it faster. So, lowering of activation energy is what enzymes, or you call it catalysts, do. That is what they do. All right. This is it. You can see the chart. Activation energy of uncatalyzed reaction. That means without enzyme and with enzyme. Without enzyme, you see that enough it will take enough more time for a reaction to occur because more activation energy is needed, while that of the catalyzed reaction, activation energy is lower. So small thing, it will just surmount the activation energy and the reaction will occur. So that is it. We can see that enzymes or reaction catalyst helps speeds up the rate of chemical reaction with the diagram or the chart you can see on the screen. Okay, what do we use enzymes for? Uses of enzymes. Alcoholic drinks such as beer and wines are produced by the fermentation of yeast, and that yeast contains enzymes which catalyze by fermentation process. So we use them in production of some alcoholic drinks. They are needed there. Number two is that digestive enzymes are added to laundering detergents to help in the cleaning of clothes and fabrics. So it's also needed in laundry detergents. Enzymes are good. They are used in manufacture of drugs. They are used in the manufacture of drugs, and enzymes are used in food processing. You can see that enzymes or catalysts are not actually bad. They are used in food babies, in brewing, in food juice, and in dairy production, in starch, pepper, and the biofuel industries. So in makeups, in eye lens cleansing, rubber, photographic, and molecular biology. So they have been used in several areas in different walks of life because of their usefulness. They have been used in several areas. So these are the uses of enzymes. So far, so good. We have been able to define what catalyst is. We are giving examples of catalysts. We have talked about enzymes as a biological catalyst, and we have also said that their work is it works by lowering the activation energy, which makes reaction faster. All right, before we end this particular video, we are going to do this particular assignment. I'm going to give it to you as your own exercise. WAEC 1990, number 12B, you are going to consider this reaction represented by this equation, and you are to sketch the energy diagram for the forward reaction showing the profile for the catalyzed and uncatalyzed system. So that is one of the things you need to do to show that you actually understood what we did in this particular video. Number two, which is WAEC 2012, number 4B, not 46, sorry. All right, okay, 2012 number 46, that is for number 3, but number 2 is one difference between positive and negative catalysts. Number 3, that is which of the following industrial process depend on the action of enzyme? That is objective question, WAEC 2012 number 46. Is it liquefaction of air, manufacturing of soap, or brewing of beer? Which of the following industrial process depend on the action of enzyme? I think we talked about it, and with that, just do the assignment and get them for further discussion and inquiry. You can get to me through my contact, WhatsApp line, or phone contact +23480-655-73229, or you can send me an email through my email address at christo116@gmail.com. So thank you for being part of this particular video. Remember, if you have not subscribed to this channel, do so by hitting the subscription button, which is red on your screen now. And as you do so, be blessed and be ready for the next video. Make sure you join the next video. Thank you.